Hello folks, back to the camera after a long time. So today I am trying to do a special topic which has been very close to my heart. It is about ray diagram for the, telescope which will form an image at infinity. So I first learned to do it when I was in class 8, and I was amazed at the perfect diagrams that they had in the books. So I always wanted to make such diagrams, and I might have drawn these diagrams hundreds of times, either for exams or for my own personal happiness, and then came with certain techniques so that I can draw picture perfect diagrams for these things, especially ray diagrams, because I don't know why I developed that interest here, and I think that I know the methods to do a picture perfect diagrams for almost every cases, including the measurements, the specific things that I do. And I often deal with this in classes that I take here in Nepal, but today I'm thinking that I share it on YouTube as well. The idea struck my mind just a few hours back, because I haven't done this on YouTube, so I thought that it would be better if I share this thing on YouTube so that all of them know the technique. So it is actually not technique, actually it is the result of experience. It's not technique, it is result of experience. So I don't want to make a hi-fi word that technique or magic or tips or like that. So it is just what I do is, it is because of experience that I could do this. So that requires my weapon is with me. So this is the scale here, this thing, the long scale that I do. So it will make the measurements picture perfect, as I had said. The first thing that you have to know is, let me draw the right side of the page, that you have. So this is the right side of the page, and this is the left border of the page, the red marks that you will see in your pages. So our working area will be only this much, from here to here. The first thing is, first you have to draw the axis of that telescope. So that's why what you do is, so from here, 5-6 lines down. From here, 5-6 lines down, you will draw this axis, and the axis should be such that, let me first draw it, and then I'll say, the axis should be such that it should be about 1 cm from here and 1 cm from here. So 1 cm from both sides in your copies, not here, in your copies. So 1 cm and 1 cm. So you measure its length. Now, so just let us say this is the boundary here and this is the boundary here. Now what you do is, first you now you will bisect this thing. You will bisect this thing and denote that point here. So let me do it here. So for me it is about 79 centimeter. So that's why I'll do it at. So if it was 80, it would have been 40. So it is 39.5. So this is the midpoint for me. So at the midpoint, you will draw the lens, objective lens. So at the midpoint, it will be the objective lens. So let me first draw the objective lens here. So first it is the axis. This is the axis, optical axis. Then I'll draw the curve. So please excuse me if I can't draw it perfectly, because I'm nervous today. So let me draw the curve here, narrow, because I have to make the lens thin here. So because the principles of optics, these things apply only on thin lenses. So this is the lens surface. So my hand trembled a bit, but still it's okay. So at the very center, you will be positioning the lens. Then let's go to the right side. Let us bisect this line as well. So let us bisect it. So it was 39.5. The measurement was. So let me bisect here. So it should be 90.75. So I have bisected this thing as well. And let's bisect it here as well. Not only there, here also. Let me bisect this thing. So bisected. So like this. So altogether, I have divided this line into 4 parts. So 1, 2, 3, and 4. 4 parts here. 4 parts. So now what I'll do is, At this position, you will form the first image, not object. We are not starting with the object. We are starting with the image. So let's say first form the first image here, and the image should be around, in your copies, it should be around one line in height, just one line. So let me draw it here. Let me draw it. So it should be just one line in your copies. So this is the first image. It is real, inverted, and diminished as you would define it, the image. So from here, I will draw the rays. Which form this image. So there should be one line is going parallel. One line is coming parallel. Actually, it is coming parallel from here, and one line comes through the optical center like this, straight, without any deviation, because light rays, when they pass through the optical center, they don't deviate. So this line should have come through the focus. This will be the focus, and we have to draw one more line, because generally we see 3 lines in the textbook. There are millions of lines, but let's draw 3. So one line will be a random line. It will be a random line which is parallel to both of these things, and then it will come to meet this thing right here. This thing right here. So these are the rays which form those parallel lines coming from infinity, and they are being focused. They will form the image at the focus. So here they are, light rays from infinity. So that means I can say object at infinity, and the visual angle here is alpha. This also will be alpha. So these are the rays like this. Now this will be the focus. Of the objective, FO. This is a large FO, and this also is the focal length, FO, like this. Now remaining that we have here. So now in the remaining distance, let us again bisect it. So we have lots of bisections. So let's again bisect it, and it will be the position for the second lens, which is the eyepiece. So here I'll make the eyepiece. Lens here, and this eyepiece lens should be smaller than this. Size smaller, but thickness a bit more. So that's why let me do it like this. So I can make it a comparatively thicker. So let me do it dot, because this is just a virtual thing here. Light rays don't reach here, just that we have considered. So this is the eyepiece. Now let us join this line. This is the light ray coming from this first image. Now from here, one of the light ray goes straight. Straight like this, and another goes through the focus. So this thing will go almost through this edge. So we have to draw parallel here. You know what happened right now is this thing was not in the middle, according to my, because this parallel line did not go through here. So that means I made a slight mistake here. But still, for you, what you should do is you have to draw this exactly at the middle, and if you do so, one ray goes from here without deviation, and the another ray which comes here parallelly, they should go through the focus. So that means it has to go through this point. So whatever it may be, it looks parallel, so things work for me. And here I will produce this such that they appear to come from the dotted lines here. They appear to come from infinity. And here I have, so let me draw it, let me produce it to show that light rays did not reach here. So this is dotted line, and my eyes will be somewhere around here. So for simplicity, we place eye here. This is the eye, and this is the visual angle here. This is the visual angle, beta. And here the eye will see, this eye will see the image around here. So this is image at infinity. So this forms our complete figure. So let me just write the symbols here. So this is O, optical center for the objective. This is E, optical center for the eyepiece. So this thing is FE, FE, and this thing is FE. Again FE. So what happened was, light rays, parallel light rays came from infinity. They formed their first image at their focus point, which is FO, FO, and this is FE as well. And this is FE, FE, FE as well. So this the lens is, this eyepiece is placed in such a way that this thing will be at its focus as well. So the light rays coming from here will travel parallelly after refraction or after deviation. So these eyes will feel that the light rays have come from here. So this will form the image here. And one thing that I want to share is, it's a very contrasting question, and we often ask it during teacher interviews. When I take interviews of teacher, this question is almost a compulsory question. What I ask them is, in this type of setup, we have object at infinity, and we see image also at infinity. Then what's the use of a telescope? Because we have defined that a telescope is something that makes far objects look nearer. But here it's not near, infinity. So what has happened here is, it is not that the image and object are the same distance. It's about the angle, visual angle. Had I placed my eyes over here, the visual angle would have been alpha. Or had I placed the light rays coming like this, and if I look from here, the visual angle will be alpha, same as this, alpha. But now the visual angle is beta. It's beta. Let me write beta here. And as you can compare, this beta should be larger than alpha. You can see in the diagram. You can see this length, this base, height is same. This base is small, this base is large. So that means this angle should be large, this angle, and this angle should be small. And when the visual angle is large, the object appears to be large. The object appears to be large. And that's how we see that magnification. So that's why telescope, though the images are at infinities, the visual angle of the rays which are entering our eyes, that will be increased. And that gives us a sensation of magnification. So this is how you draw a ray diagram of a telescope with image at infinity perfectly, almost perfectly. So I think there is no way that you can deduct marks here. Anybody can deduct marks here, because every measurement have been drawn to fineness, and I myself cannot deduct any marks because me myself who have done it. So this is how you